All right, so we're gonna look at 2A here for a second first. This is from 2018, number 2. And basically what this one is getting at is solving for a sample size for a confidence interval that was 95%. And you're given the confidence interval and it's a proportion. So in order to find a key value, I guess this is how the confidence interval was built. Some critical Z times the square root of the sample proportion and 1 minus that over some number. And the goal here, the whole way, is just to find this n. And before you jump in, you got to figure out what the sample proportion would have been. So in this case, it's not too difficult, but you got to remember that this sample proportion would have been in the middle of these two numbers. So to find the middle of those two numbers, you can just take your lower bound, your upper bound, and just find the average. And in this case, p hat would have been 0.7. So once you have this number, you're going to be able to work backward, and you really just want to focus on the margin of error here, and figure out exactly what the sample size was. So here's what the entire setup could look like. So I know that the upper bound estimate was 186 or 81.6%. So I know that 0.186 equals 0.7 plus 1.96 times the square root of 0.7, 1 minus 0.7 over n. And in this case, just a little bit of algebra here, we'll find out what our n value is. So first thing I want to do is just subtract the 0.7 from both sides. So subtract 0.7, subtract 0.7, and we have 0.116 equals 1.96 times the square root of 0.7, and 1 minus 0.7 is 0.3 over n. So the next thing I want to do is just divide that 11.116 divided by 1.96. Get that over here in the shot too. So in this case, 0.05918 equals the square root. And 0.7 times 0.3, might as well do that, it's 0.21 over n. And now I can square both sides. So squaring each side will give us a little bit closer here, 0.035. And then last two steps, just multiply both sides by n and then divide by 0.0035. And don't forget to avoid some round off error here. So in your calculator, you've already got this full non-rounded answer. We're going to use that one. So we're going to take 0.21 divided by the answer, and this will give us an n, 59.95. And in this case, the question was like, how many people did the environmental science teacher select? And it must have been 60. So really, really close to 60. So n would have been 60 in this sample. Now, going on to part B and C. Part B here. It says, given that the method used by the environmental science teacher, the method used, he basically asked students whether or not they recycle, and they're asking about which type of bias this could have been and how it might have affected the point estimate. So because of the teacher asking, this likely leads to a response bias. And the reason is students are more likely to lie to a person that they don't want to come across as unfavorable. So that's likely what happened here. And that would have an increase in the actual proportion. Since students do not want to appear as if they do not recycle. To the environmental science teacher. So what this would have done is the 0.7 that this science teacher got was probably a high estimate, and that's part of this question too. How might it affect the point estimate? This bias likely increased the sample proportion compared to the actual proportion. Of people who regularly recycle. And basically you want to make sure you do the two parts there. Explain how it might have been introduced, and that would have been because of the asking of the questions in person. And then the other part was the how does it affect the point estimate? So make sure both of those are addressed there. And then the last part, kind of interesting, propose this alternate method to get the actual data collection. So it says, take a random sample of 300 students, and they get the following instructions. You flip a coin, and if it's heads, just write no. And then it doesn't matter whether you recycle or not. If it's tails, you answer truthfully. So in this case, it's trying to get rid of some of that bias that people wouldn't lie and face to face to the science teacher. So you can figure out the expected number of students in the sample of 300 who would be required to respond to no, because it's basically going to be fair coin. It's going to be about 50% of the coin flips are going to come up heads. So in this case, for part I, you can expect 300 times 0.5, and this represents the sample size, or n, and this represents the probability of heads. So in this case, we can expect 150 students that would be required to say no, just based on the coin flip. So it's then moving on to the next piece, which was like, all right, so this actual sample gives us 213 said no, and based on the results of the sample, give an estimate at the high school who would respond yes to this question. So what we want to basically do is take these 150 that we know would have flipped no just from the coin flip, and that would leave us with, so based on truthful responses, the expected counts would be, the 213 said no, so we can take out 150 of those that would have been expected from the coin flip. So if we take 213 and subtract off 150, give us 63 people respond no, truthfully. And what we can use that for is just to flip that around and find the percent who would have said yes. And that leaves us with 87 that would have responded truthfully yes. So 87 truthfully responded yes. And as a proportion, it says give a point estimate for the proportion. So we can estimate p hat there to be about 87 out of 150. And in this case, that is 58%. And that's all you need to do for the 2018 number 2 question.